Okay. Last meeting on Monday, we discussed the formulas and derivation for the analysis of sloping soil for infinite and finite soil. Okay, or finite soil slope. Okay, so under infinite slope, we discussed the factor of safety against sliding without the seepage or without the pore water pressure. Then also the factor of safety against sliding with seepage. Okay. Then also we determined that some reference uses this equations or this formula sine beta cosine beta, and some reference uses this cosine squared beta tangent beta. Okay. Uh, then also, we determine that in a finite slopes, okay, we need to solve for frictional forces, then cohesion forces, then divided by the force that will cause impending failure in our sloping soil. Then also, we determine that if we set the factor of safety equals to 1 and determine the height, we are getting the critical height or the maximum height for critical equilibrium. Okay, this is when your factor of safety is equals to 1. Then also we determine the stability number and their stability factor. And for factor of safety that is greater than 1, okay, for factor of safety that is greater than 1, we are going to use the formula for each, which is C sub D and phi sub D. Okay, ano yung ibig sabihin ng subscript ng D? The subscript of D is meaning it was the demand cohesion or the cohesion and in angle of internal friction develop along the potential surface. Okay? Sila yung parang demand dun sa ating sila yung parang actual or demand load dun sa ating failure plane. Then also the other factor safety in terms of phi and cohesion is given by this equation. Okay? This equation and this equation. Then also we determine that Fs, Fe, and Fc are all equals. Okay? So yun yung summary for soil stability. So now we can solve if we are going to use a retaining wall. Kailangan pa ba natin gumawa ng retaining wall, or maybe the sloping soil is enough for safety of our sloping soil. Okay, so let's try to have an example problem. So this example problem number 1 from Braha Mdas, Principles of Geotechnical Engineering. So the problem is for infinite slope shown in this figure 15.9. Consider that there is no seepage through the soil. So determine number 1, the factor of safety against sliding along the soil rock interface. And number 2, the height h that will give a factor safety of 2 against sliding along the soil rock interface. Okay, so let us consider the problem. Understand the problem. Okay, sabi niya dito, there is no seepage assumption. Okay. So also, this is an infinite slope. Okay, bakit siya infinite slope? Because of this figure. Okay, assuming that you have a very large okay, sorry. Naghang yung yung viewer. Wait lang class, naghang yung yung annotator. Yan, okay. So, asan tayo? So, this one. Okay, so this is an infinite slope because mapapansin natin sa figure there because meron siyang infinite na parang continuous lang yung ano niya, yung sloping soil niya. Ang ganito lang. Okay? Then you have an angle beta along the horizontal which is 25 degrees. Okay? Total height of your sloping soil or yung thickness of your soil is 2.44 meters. The datas or the properties of soil with gamma is equals to 15.72 kilonewton per cubic meter, a cohesion value of 9.58 kilonewton per square meter, and an angle of internal friction to be 15 degrees. Okay? So, balik tayo dun sa summary. So, according to the problem, sabi niya, infinite slope, consider without seepage. Okay, without seepage. So maybe therefore the working equation is this one. Pwedeng ito or pwedeng ito. Depende kung ano yung gusto nyong equations. Okay. So let us consider this one because this problem comes from Braha Emdas, and kay Braha Emdas ang equations na ginagamit niya is this one. Okay, so our working equation is C over gamma H cosine squared beta, tangent phi, tangent beta. Okay, so ayan. Ang problem sa number 1 is what is the factor of safety? Ano daw yung factor of safety of your soil na agad? Yung using this height na 2.44 meters. Okay. So let us check kung ano pa yung kulang dun sa working equation natin. Sabi dun sa working equation natin, cohesion value, we have this one, gamma, H, beta, and phi. So therefore, we are this problem A is very straightforward. We can easily solve for the factor of safety. So C, which is 9.58, gamma, which is 15.72, your H to be 2.44 meters, beta is 25 degrees, okay? Your phi is 15 degrees. So therefore, the factor safety is equals to 1.23. Okay? So meaning hindi pa to magkakos ng failure with height equals to 2.44 meters. You still have a factor safety of 1.23. Next, part B of the problem is what is the height H that will cause a factor safety of 2.0? Okay? So, going back to the working equation, let us check ano yung kulang natin. C, we have your cohesion value still the same. Your gamma still the same. H, unknown. Beta, tangent phi, tangent beta, and the factor safety. Okay, so therefore, direct substitution, we can get this value of H, which is equals to 1.12 meters. Okay, so what can you say about part A and part B? What can you say about part A and part B? Okay, at H is equals to 2.44 meters, the factor of safety is equals to 1.23. Now, when your H is equals to 1.12 meters, approximately 50% or so yung nabawas, the factor of safety is equals to 1.12. Sorry. The factor of safety is equals to 2. Okay, so what can you say about this factor of safety and the height of slope relationship? Okay, we can say that if our height increases, the factor of safety decreases. Or if our height decreases, the factor of safety increases. So if we try to graph the H and Fs relationship, HFS relationship. So if we increase H, bababa yung factor safety. Pag in-increase yung H, tataas yung factor safety. So therefore, we can say that this is the graph. Okay. So this is, let's say, this is 1.0. Okay. So if we increase H, tataas yung, if we increase H, bababa yung factor. Should be this one. So if we increase H, the factor safety decreases. So this one. Okay. So if we increase H, the factor of safety decreases. Okay. So that is the H and FS relationship. Okay. So example problem 2 from the book of Braha Emdas Principles of Geotechnical Engineering. Okay, let us recall this problem 15.9. Okay, if there is seepage through the soil, as shown in the groundwater table coincides with the ground surface, what is the factor safety now if your H is equals to 1.16 meters and your gamma saturated is equals to 18.55 kilonewton per cubic meter. So this time we are now considering seepage in the soil. Okay, so let's go back to the summary for formulas. Okay, considering now your seepage, so ito siya, ito yung working equation natin. This will be your working equation. Okay, so let us try to solve for this one. The working equation is Fs is equals to C prime over gamma sat H cosine squared beta tangent beta plus gamma prime tangent phi over gamma sat tangent beta. Okay, so from this working equation, let us see kung ano pa yung kulang natin. So we have the cohesion value, gamma sat, we have the H, we have the cosine squared beta and tangent beta, tangent phi and tangent beta. Gamma sat, we already have this one. So what is this gamma prime? Gamma prime is basically gamma sat minus the the unit weight of water. Okay, so this is the effective buoyant unit weight. Okay, therefore, this gamma prime is equals to 18.55 minus 9.81. Okay, so ito yung ilalagay natin for the gamma prime. So we can now have the factor safety is equals to 9.58 divided by 18.55 times 1.16 cosine squared 25. Okay, tangent 25 plus 18.55 minus 9.81 divided by 18.55. Tangent 15, that is your phi is 15 degrees, and your beta is 25 degrees. So therefore, your factor of safety is equals to 1.43. Okay? So, ito lang naman yung mga problems in infinite slopes. So, for infinite slope soil, kahit without seepage or seepage, the equation, the working equation is your ultimate weapon in this kind of problem. Okay, so yun lang yung kailangan mo for this kind of problem, since very direct lang yung ang pag-solve for this infinite slopes. Okay, next one, example problem 3 is again from the book of Braha Emdas Principles of Geotechnical Engineering. So this one, we are now considering finite slopes. So bakit siya finite slopes? Okay, so let us read the problem. A cut is to be made in a soil having a unit weight of 16.5 kilonewton per cubic meter. The cohesion value of your soil is 28.75 kilonewton per square meter, and the angle of internal friction to be 15 degrees. Okay, the side of the cut slope will make an angle of 45 degrees with the horizontal. What should be the depth of the cut slope that will have a factor of safety of 3? Okay, so bakit ito tinawag na, finite slope? Because of the word, okay? So take note of this word, because of the word cut. Yan, cut slope. Okay, so if you cut, kapag may nakita kayong word na cut, therefore that is an finite slope. Okay, so ang sabi dito, nag-cut daw sila ng sloping soil that cause an angle of 45 degrees from the horizontal. So let's say this one yung total, yung soil. Ngayon nag-cut sila dito. Okay, sorry, nag-cut sila at an angle of 45 degrees. So maybe this one. Okay, So, ayan. So, anong mangyayari dyan? So, kung ganyan yung, kung ganyan yung nangyari, nag-cut sila na ganyan, this will cause a slope ganito. Ayan. So, this is 45 degrees along horizontal. Okay. Now, your gamma is equals to 16.5. Your cohesion is 28.75 and the angle of internal friction to be 15 degrees. The problem is asking what should be the depth. Okay, ano daw yung depth that will have a factor safety of 3. Okay, so let us try to solve for this problem. So let us write the given. Okay, your phi is 15 degrees, the cohesion is 28.75. Okay, so we have this one. If Fs is equals to 3, then your Fc and Fv should be both equal to 3. Okay, from our definitions that this factor safety are all equals. Okay, so if your Fs is equals to 3, this one is also equal to 3, this one is also equal to 3. So bakit natin kailangan yun? So balik tayo dun sa summary ulit. Okay, according to the problem, naghahanap siya ng H that will cause a factor safety of 3. So we cannot use this equation. We don't have enough given. We cannot also we can't use this equation because this equation is for a factor safety of 1.0. This is for the critical equilibrium, meaning ito yung maximum height natin. So we cannot use this one. So therefore, we only need to use this factor safety that is greater than 1, solve for the H, this one. Okay, so what is the, ano yung kulang natin dito sa equation na to? Okay, so yung kulang natin sa equation na yan, so let us get that equation. Yan. So we need to find the cohesion and angle of internal friction developed along the failure plane. So we need to find CD and phi sub D. Okay? Kailangan pa nating hanapin yan. So how to get CD, phi sub D? So pwede nating makuha yan in other relationship of factor of safety in terms of phi and C. This one. Okay, pwede dito and pwede rin dito. Okay? So doon natin siya kukunin. So other factor of safety in terms of phi and C is given by F phi is equals to tangent phi over tangent phi D, phi prime of T. FC is equals to C over C prime of T. So your Fs is equals to 3, then this two factor safety is both equal to 3. So substitute natin yung 3 dito. So solving for C prime of D, we have 9.58 kilonewton per square meter. Then similarly, your Fv is tangent phi over tangent phi prime of T. So solving tangent P prime of D, we solve this tangent 15 divided by 3. Okay, so this will be your tangent phi prime of D. So solving P prime of D is the tangent inverse of the tangent 15 over 3. You now have 5.1 degrees. Okay, now substituting the preceding values of CD and P sub D into this equation. Okay, so H is equals to 4 times 9.58 divided by 16.5. Your sine of 45 degrees. P of D, which is 5.1. 1 minus cosine 45 minus 5.1. You get your H to be 7.03 meters. Okay, so this H will cause a factor of safety that is equals to 3. Okay, so do you get it, class? Okay, so ganun lang. Kapag hindi yung factor of safety nyo is not equals to 1 and you want to solve for the H or the critical, the height that will cause that factor of safety in finite slope, you need to go back to the other relationship of factor of safety, this one and this one. Okay, any questions? Okay, so other example problems in finite slopes is to determine yung mga forces. So ito yung kalimitan lumalabas in the board exam. So this example problem is a past board exam or past board civil engineering exam. Okay, so this one is again a finite slope. So a cut is slope is to be made as shown in this figure. So the unit weight of your soil is, I think this is 15 point, let's wait lang, 15.74. Okay, this should be 15.74. Okay, so the unit weight of our soil is 15.74 kilonewton per cubic meter. And an angle of internal friction or angle of friction to be 10 degrees. Okay, the soil has a cohesion of 28.8 kilonewton per square meter. Your trial failure plane makes an angle of 30 degrees, as you can see by this theta. Ito yung failure plane mo. And the cut slope makes an angle of 50 degrees. So ito yung cut slope natin, angle of 50 degrees. So if the height of the slope is 3 meters, number 1, compute the force that will cause sliding. Number 2, compute the resistance of the sliding force. And number 3, compute the factor of safety against sliding. Okay? So, ayan, ito lang yung maganda dito sa finite slope. So, we need to find equilibrium forces. Yan, hindi siya direct substitution. So, ito lang yung medyo challenging sa part. Okay. So, a factor of safety against sliding, given this finite slope is given by this formula, FF plus FC over W sine theta. Okay, so balikan natin ano yung mga forces na to. Okay, so recall that if you have okay, sorry for the interruption. Nag-restart yung Wi-Fi. Okay. Can you hear me, class? Hello. Hello, class.
Yes, yeah.
Okay yung audio, hindi naman hindi naman nagpuputol-putol.
Konti, sir.
For a few minutes. Wait. Okay. So let us find the forces, which is FF, FC, and W sine theta. So hanapin lang natin nasan siya ulit yung mga forces na yan. Okay. So if you have an angle of theta in this along the potential surface. So if you recall, kapag magta-translate tayo ng angles, di ba ganyan? So ito, this will be your W cosine theta. And this one is W sine theta. Bakit? So if we consider this triangle, consider natin yung triangle na to. Okay. Consider that triangle, that is this one. Wait lang. Okay, hello. Ayan. Okay, siguro to. Okay. So if we consider this angle theta, then this one angle theta, and ito, di ba, 90 degrees this one. This is 90 degrees. So if meron kang load W dito, and you don't know what is this angle, okay? Let's say W1, ito is W2. Okay, this is 90 degrees. So you know that W1 should be perpendicular to this hypotenuse sides. Yung hypotenuse dito sa sides nito. And this W2 should be parallel to this side. Okay? So yan yung alam natin. W1 should be perpendicular to this side and W2 is parallel to this side. And W is acting downwards. Okay? So if we project again, if we project this W, this W1, this is 90 degrees. So dito, alam natin to na, let's say this is alpha, that is equals to 180 minus 90 minus theta. Tama? Ito, 90 plus theta plus alpha. Therefore, 90 plus theta plus alpha is equals to 180. Okay, so if this is alpha, this is 90. Therefore, this is, tama, this is beta. And according to the parallel sides theorem, okay, this one. So this is also beta. Then also for theorem for parallel sides again, if this is beta, therefore also this is also beta. Kung beta to, this is W2, pwede mong ilagay yung W2 dito and you now have a force polygon. Ito ay 90 degrees. So yung pagitan ng W1 and W2 is 90 degrees. Okay? So therefore, this W is the hypotenuse side and this W1 is equals to W cosine theta, which is exactly this one. And W2 is equals to W sine theta, which is equals to this one. Okay, so doon na-derive yung mga ganyan. So for your for your future reference, if you have an angle of theta dito sa inclination na to sa inclined plane and you have a W or a forces that is perpendicular and parallel to that plane, you have now the same angle. So kapag may angle ka lang na theta dito, angle ka lang din na theta dito. Okay? So ganyan yung ginagawa. So you can use this theorem in designing steel purlins. Okay. So going back, W cosine theta, W sine theta. So if you remember, 'di ba, ang the general equation for the factor safety is kung ano yung capacity and yung demand. Ano yung magre-resist dun sa force that will cause sliding divided by dun sa actual force na magko-cause ng sliding. So we all know that this W sine theta is the actual force that will cause failure or that will cause sliding in this finite stone. Okay? This W sine theta, siya yung magtutulak ng soil na to. Siya yung magtutulak ng soil na to. Yung W sine theta na yan, yung force na yan. So therefore, this is your the demand load. And ano yung kukontra sa W sine theta? Ang kukontra sa W sine theta is this FF and this FC. The frictional force and this cohesion force. Okay, so FF is frictional force, that is mu times N. And your FC is equals to C times the area along the trial failure plane. Okay, so that is this one. So yung free body diagram natin, yung complete free body diagram natin is W2, ito. This is equals to W sine theta. W1, that is W cosine theta. Also, you have an angle 30 degrees over here. Then, draw na rin natin yung normal force. So, normal force or normal to W1 is equals to N. And you need to solve F1 and you need to solve F2. F1 is the frictional force, F2 is the cohesive force. Okay, so let's try. Okay. Katulad dito sa binigay ko na to sa sa summary of this one. Okay, di ba sinabi ko sa inyo that yung pagsosolve lang for a finite slope is your first approach is to determine this BC, this length BC. Ito yung malaking, ito yung length na makakatulong sa atin to determine the W sin theta. Yan lang yung kailangan natin, yung total weight W to find this W. Okay, so this BC comes from the triangles. Okay, yung triangle na to and comes from this triangle. Okay? So if we consider this big triangle, this x1, yan, ito yung big triangle na yun. Okay? So ito siya. This is AC. This is 30 degrees. And this is 90. This is x1. Okay. You know, we all know that x1 minus x2 is the length BC. Yan yung kailangan natin to determine the volume of the soil. Okay? So yung x1 natin is basically you have your h. So that is h over tangent 30. Okay? So you have here the length x1 which is equals to 5.2. Okay? Next is to find this x2. To find that x2 is consider this triangle. Okay. To consider the triangle, yan. So this is now 50 degrees. This is AB. And this is x2. And this is h. Therefore, your x2 is equals to h over tangent 50 degrees, which is exactly this one. Okay? Then, we can now solve for BC. Yung BC natin is the difference of x1 minus x2. Okay? Yan yung BC natin, yung difference of x1 minus x2. So why we need to find BC? Okay, so solve lang natin tong BC. Okay. So to find this BC, okay, BC that is 2.68 meters. So paano ba natin kukunin yung total volume of this W? Ito yung total weight Total weight that will cause impending failure. Dito nanggaling yung lakas ng total ng W2, ng W sin theta, the total weight. Okay? So paano natin siya makukuha? So i-remember the area of triangle. Okay? So if you have this triangle, itong triangle, and this is an iscaline triangle. So meron ka ditong sides length, let's say B. And this one is your H. Okay, so the area of triangle is basically base times height over 2. Then, what is the volume? So, paano makukuha yung volume? So, di ba, area times height lang naman yung volume. Okay, so to find the volume, you need to consider 1 meter strip, okay, away from your keyboard. So, considering 1 meter, that is now your volume. Then, the total weight is equals to the volume multiplied by the unit weight of your soil. Ito na yung total weight natin. So that is why we need to find this area of triangle. So to determine the area of triangle, you need to find BC, the length BC. Okay? So therefore, the total weight is 2.68 times the height 3 over 2 times 1 meter strip multiplied by the unit weight, you have the 63.27 kilonewton. Okay, so hanapin na rin natin yung AC. Kasi kailangan natin ito mamaya in FC or the force that will cause cohesion. Okay, so kailangan din natin yan. Sige, solve lang natin dito and I will discuss so bakit natin siya kailangan i-solve. So 30 degrees, this is your length AC, this is your length H. So to solve for AC, basically that is sine 30 degrees is equals to opposite over hypotenuse, which is H over AC. Therefore, your AC is equals to H over sine 30, which is equals to 6. Okay, so ang ibig sabihin yung total length nitong AC na to, this AC is 6 meters. Okay? So, dyan lang yung AC natin. Okay, dyan lang yung AC natin. So, going back to the problem, what is the force that will cause sliding? So, the force that will cause sliding is basically this W2 that is equals to W sine theta. Okay, so you have here your W multiplied by sine theta. You now have 31.64 kilonewtons. Okay, this will cause sliding in your finite slope. Okay, then solve na rin natin yung unknown forces for the next solutions, yung N. We need this N. Yung N na to is equals to W1, right? The summation forces along this line, kung ano yung nasa taas niya, yun yung sa ilalim. So therefore, this W1 is equals to N. So yung W1 natin is W cosine theta. And therefore, you have here the N normal force, which is 54.79 kilonewton. So again, kailangan din natin yan. So we now have your N, which is 54.79 kilonewton, and your AC, which is equals to 6 meters. Okay, now the problem is asking what is the resistance force, or what is the forces that will resist that sliding force. Okay, so basically kung ano yung capacity natin. So yung capacity natin is yung FF plus FC. Okay, so solve muna natin yung FF, yung frictional force. According to the equation, your frictional force, according to physics, that is equals to mu times N. Tama? Mu is the coefficient of friction, and N is yung normal force. Okay, so how to determine this mu? Ang meron ka lang is angle of internal friction. So if you recall your physics, the tangent of your angle of internal friction or angle of friction is equals to your coefficient of friction mu. Okay, so this tangent phi is equals to mu. Therefore, you can solve for F1 or your FF, the frictional force. So that is tangent phi times N. So that is tangent 10 times the normal force, whereas your normal force is W sine theta, which is equals to 54.79 kilonewton. Therefore, your F1 is 9.66 kilonewton. This will be your frictional force. Now, determine the cohesive force. Okay, the cohesive force, basically, the stress times the area, the contact area. Yung contact area natin for cohesive force is this one. Tama ba? So, hindi yan area. Width lang yan. Nasaan yung length? Yung length is yung considering 1 meter strip. So, pag tinignan natin siya in 3D, you have this one. Ito yung, okay. So, cut natin to. Makikita mo yung plane na to. This is your length AC. And this is your considering 1 meter strip. Okay. So, yung frictional force is along this one, FF. And yung cohesive force is this, nandito. Sa along the plane na yan. So, FC. So, di ba yung force na yan is basically stress times area. Yung stress natin is the cohesive, the cohesion, and yung area is this contact area. So, that is AC times 1. So, that is why we need to solve for AC. Kaya pinasolve ko yung AC kanina. So, yung FC, basically that is C times the area along the trial failure plane. So, yung FC, considering 1 meter strip, is cohesion, which is 28.8, times the AC length, which is 6 meters. This is the length along the trial failure plane. And considering 1 meter strip, therefore, your cohesive force is 172.8. Okay? So, summing adding the F1 and F2, FF and FC, therefore, this will be the total resistance force that will resist the sliding force W2. So that is equals to 9.66 plus 172.8. You have 182.46 kilonewton. Okay? So may questions pa kayo regarding this resistance force? Okay? Sige. Then, the factor of safety. Number 3. What is the factor of safety? So, the factor of safety is FF plus FC divided by W sine theta. So, i-divide lang natin yung na-solve natin for number 1 and number 2. So for number 2, that is your capacity, which is the 182.46, and the impending force that will cause sliding is 31.64. Therefore, the factor of safety is 5.77. Okay? So ganyan lang yung pagsosolve for finite slope. Okay, so summary of our solution for finite slope is number 1, to determine the length BC. If you determine the length BC, you can now solve for the total weight W. And if you solve for total weight W, you can now solve for W1 and W2, or which is the W cosine theta and W sine theta. W sine theta is the force that will cause sliding. W cosine theta is equals to the normal force. Okay, and you need to solve also the length AC that along the potential failure plane. Okay, so na-solve mo na yung W, alam mo na yung cos W sine theta. Next is to find the resistance force, which is FF and FC. Yung FF is equals to the normal force times mu, and yung FC is yung length AC multiplied by the considering 1 meter strip, and the cohesion of your slip. Okay? So ganyan lang yung pagsosolve for a finite slopes. So for any more further questions, may question kayo, class? Wala na. Okay, so that's it. And thank you for listening. So we don't have class on Friday. So I standby lang kayo if I will announce if you have exam on Monday. So no, Monday or Wednesday. So let's see. Okay, thank you for listening.